that you're here. For everybody joining in, if you aren't aware, today we'll be covering two main topics. One will be how to transfer files to and from the HPC using either a GUI or a graphical user interface like FileZilla or WinScp, or the command line with the scp command. In the second part of the talk, I'll answer your question in a second, Seth. In the second part of the talk, we'll go over how to run R on the HPC and how to submit a job with R script on the HPC as the general overview. And Sebastian asked in the chat, what's the benefit of using the terminal over something like Visual Studio Code, or is it essentially the same? It is not the same, Sebastian. I think it comes down a lot to preference. I think Visual Studio Code allows you a more user-friendly setup, as in you can point and click in your scripts to modify them. It might be more familiar with usual text editor that you're used to, while the terminal, if you're using a text editor like Nano, it might be a bit different, and there's no point and click, it might be a bit more clunky and harder to get used to. In saying that, I do not use Visual Studio Code myself, so maybe users of it have more input on that side. But yeah, I think it comes down a lot to preference and how you like your workflows to be set up. And I think Jacob is a Visual Studio Code fan, while Legana prefers terminal. I think we can probably, I wish I knew how to do polls in Zoom, and I would have done a poll. I think we're looking for what session to have for the next lessons of this course, and I think we could probably have Waitama present on how to use Visual Studio Code to interact with the HPC one day, if there's interest. Okay. Oh, there's some interest from Roy. If you are interested in learning how to use the Visual Studio Code to interact with the HPC, please drop a comment. Great point, by the way. Use what you're familiar and comfortable with. Okay, it's 5 past, so I'm gonna share my screen while we wait a couple of seconds for people to join. Can you all see my presentation?
Yes.
Thank you. It's 5 past, so I think I will start unless there's more questions in the chat. I'm not able to see the chat at the moment, Natalia, so if there's questions that need addressing, maybe interrupt me, if that's okay.
No worries.
So week 2, we're gonna cover how to transfer file to and from the HPC and how to submit jobs. Before we do that, especially for newer user, a quick refresher on what we covered last week, where we showed you how to log in into the HPC. That means if you're working from a Mac or from Linux, you will open the terminal, which comes pre-installed and looks something like that screenshot on the bottom right. While on Windows, you will be using something like PuTTY, which you have to download, or PowerShell or Command Prompt, which are sometimes already installed. And once you've opened your terminal of choice, then it's a matter of logging in with the command at the top. Remember not to have the first S as a capital letter, because SSH is all lowercase. And then your JC ID, replace these 6 zeros with your ID, at Zodiac, blah, blah, blah. Remember, if you're logging from off campus, add the port 8822 at the end of the command, and then enter your password. And something that people struggled a bit last week with, and I struggled with myself as well when I first started, is that when you enter your password, you're not going to see the characters being typed. That's a security feature. Just go ahead, type it out all at once, press enter, and it should work. And if it did work, you'll be presented with a screen like the following, when it tells you that you've logged in into the HPC. And you'll have your command prompt at the bottom with your username and the login node that you're logged in into. So to follow along with today's code, especially once we get to the scripting and submitting jobs, ideally you should be able to be at this stage, logged in into the HPC and ready to follow along. So today, before we get to the actual scripting, I'll show you how to transfer files with FileZilla and WinScp for Mac and Windows respectively. And then how to transfer file with the scp command through the command line. And finally, I'll show you how to submit jobs to the HPC. I think that's all for this presentation. I'll share a different screen now, which is going to be this one. I'm just sharing in the chat some useful links, and these include the download link for both FileZilla and WinScp. Remember to download the client version and not the server version. And then I also added the links on how to set up both FileZilla and WinScp that Wayne and his team produced. You can find them at the Confluence website on the GSU website. And there's a lot of other useful links in those resources. So please get familiar with those, as they can help you answer a lot of your questions when you first use the HPC. And I've also added the respective lessons from this course that we have on our Code R website. So I'm gonna, if you're downloading FileZilla, this is the one on the left. Download FileZilla client is the one you will follow. And if you're downloading WinScp, just press download now and you should be right. And this is what the documentation from Wayne and the HPC team looks like. It's pretty detailed, so that should be enough for you to get started. I'll quickly show you how to set up FileZilla. I do not have a Windows, so I cannot show you WinScp, but if there's any questions and you're struggling, just interrupt me and we can help you out. So new screen, we're going to share FileZilla now. So I've installed FileZilla, and you can see on the left, it's showing my local site. This is my laptop, and currently I'm in the users. Lorenzo is my username and desktop directory, and I can see the file within that directory. I do not have anything here on the right side where I want to connect to our remote site, which in this case is the HPC. To set up a connection for the HPC that you can reuse at a later date and save yourself some work, you're going to, can you see my cursor? Maybe I'll try and make my cursor visible.
We can see it.
Oh, okay, awesome. I don't know how to make it red and popping up next time. So top left, this symbol that looks like 3 computers are connected to each other. We'll open up this site manager window. And if you're new, I've already have my HPC set up, but if you're new, just press new site, select the SFTP protocol. The host will be the same as what you add to your login command. So zodiac.hpc.gsu.edu.au. The port is 8822. Logon type, setup ask for password. Or if you have an SSH key, I think maybe you can use key file, I'm not sure. And then your username is dc blah, blah, blah. And you can press connect. And now whenever you want to connect, it's going to ask for your password. And now once I've connected, I can see here on the right side that I'm connect it to my home folder within the HPC, which is defined, which is called with my GC number. And I can see all the files within that folder. Now, if you want to start moving files from your local machine to the HPC, you will simply travel to the directory where your file is located. In my instance, I've got a file on desktop. Maybe I want to transfer my important data that I received from a collaborator or entered manually into my laptop onto the HPC. So maybe here I will have create directory and create a directory for my new project. Okay, I've got my new project set up and I can simply drag. And at the bottom, it appeared very quickly, but it showed us the progress for that file transfer. And if nothing is left, means that transfer was successful. And if I look within my new project directory, I should see my data file. To transfer the other way, it's the same, just dragging the other direction. I believe WinScp is similar once set up. Unfortunately, I cannot show you how to set it up as I do not have a Windows myself. But if you do have a Windows and you like to set it up, please try and do it now with the instructions I shared in the chat. And if you have any issues, we can help you now interactively all together. I've got a lot of cautionary tales from using FileZilla and from doing anything in my life in general. As I once lost a whole folder, and twice lost a whole folder with my data in it. Once was using the rm command within the HPC, and once was, I think I selected a file like this, and without knowing, there was also a directory, maybe in the same folder selected. And it was, let's see if I can have a good example. Yeah, maybe something like this. I had this directory selected, and maybe I had a file here that I wanted to select, or maybe another directory. I didn't see that it stayed selected to directories or to files. Maybe I had many files selected, and I just went on to delete, and I deleted it. And I deleted a whole project worth of progress that took me 3 months to produce. So be careful how to use it. It can be a bit clunky sometimes. There's no prompt to confirm or show you exactly what you're deleting. So please be careful. As a reminder, what you delete on the HPC doesn't go in the bin, just gets deleted off the face of Earth. So if you would like to learn how to use FileZilla, please try ahead if you have installed it and set this up. Same with WinScp. And while you do that, I'll show you an additional way to transfer file, which is through the command line. If you do have any question at this stage, please feel free to interrupt me. We have time and we're here for that. I'm going to share now my terminal. Can you all see my terminal?
Yeah.
Yeah,
Yes.
Awesome, thank you. So I've opened my terminal in Mac, and I've got the prompt here. I'm currently not logged in on the HPC, so I'm going to start by, oh, I don't even need to do that for SCP. Transferring files with the command line. We're going to be using this command, SCP. If you're using PuTTY, I believe you'll need a different version of SCP, which is a PSCP. Sometimes it comes installed with PuTTY, sometimes it doesn't. If you don't have it installed, there should be instructions online. If you want to try and install it now, we can help you. If you install it later and you have trouble, you can come to our Slack channel and we can help you there. So how do I use this SCP command to transfer file? The general structure is username at server, and then my file path, file name. This is the source, the file that I want to transfer from, and then the tool will be username at server at directory to transfer to. What does this mean? Let's put this into use with a real world example. Let's say I have a file on my desktop. I'm gonna first show you where the file is by changing my directory to the desktop with the cd command, ls command to list the file, and the file I want to transfer is my important data, which contains, if I do cat my important data to show the whole content of the file, observation ID, record for temperature, and record for humidity. And you can see that the 5th day was 50 degrees and 100% humidity. So your data logger is probably broke. Now I want to transfer it to the HPC so I can start running my fancy analysis. It's going to take a lot of days on these 5 raw files. To do that, I'm going to use scp. And to start with, I want to give the path to the file on my local machine. So I'm going to use the tilde for my home directory. Within my own directory, there is the desktop, and within the desktop, there is my important data. Once again, if you're new to the HPC, Pete pointed it out last week, you can use the tab key to autofill. So I only have one file called my important. I press tab and it fills automatically the rest. And then I want to transfer it to the HPC. So to do that, I'll use my username, followed by the server name, double quotes, and then where in my HPC folders I want to save it. And in this case, I just want to save it to my home directory, which is denoted by this symbol here. So this should be enough. I press enter. It asks me for my password. If you set up an SSH key, it wouldn't ask you for a password. And you saw that while I typed it, nothing showed up. And then this was a pretty small file, so it was completed very quickly, 100% complete. And now if I go back to FileZilla, I could see that file there. Or alternatively, I could log in into the HPC and check for myself. And I'll show you that in a second. If you want to transfer it the other way, just invert the order. So scp, I want to transfer from the HPC this time. So I'm going to use my HPC user ID, followed by the server. Where this file is located, it was in the home directory, and this time I want to give the name of the file. In this case, you notice it won't pre-fill because I'm not currently submitting this job from the HPC, so it does not. My local computer is not aware of what files I have in the HPC, so I just have to enter it myself. And this time I want to save it to downloads. I run. Once again, it asks me for the password for permission, and I just type the whole password and you see nothing appears. That's a security feature. Don't worry if that happens. I press enter, and the download was 100% successful. To check that, I might list the files in my downloads folders with the ls command. And there's way too much data there, but what was it called? My important file something. It's somewhere in there. You will have to take my word for it. Okay, that's all for SCP. I'll just quickly show you how, if you're using PuTTY, the command will be a bit different. So instead of SCP, you have PSCP, followed by the SCP option. And then you'll have your source and your, which is the same, it would be like the desktop and my important file. And then the HPC, blah, blah, blah. I believe this is how it works. I've not tested it myself. So if you're running PuTTY on Windows, maybe try it out and we can figure out together whether that's the foolproof way to achieve it or not. Oh yeah, good point from Legana. I'll quickly show that. Say I'm using, I'm running this command from off campus. I need to add the port 8822, the same as if I was logging into the HPC. To do that, you want to have the capital P, and the port goes straight up after the capital P. You don't need the space in this case. And then I will have, as before, desktop, my important data, and then DC blah blah blah. With the zodiac, DCU blah blah blah, and that should do the trick. Any questions so far on file transfer? In particular, if you've tried to follow along, has it worked for you or anything?
There is a question in the chat.
Yeah. If you have many nested folders, is there a way to make sure all the files have been transferred successfully from your local machine to the HPC? I am not sure. Maybe
you should get an error. Any software worth its weight in gold will give you some sort of error message. However, there may be situations where you don't know, like something, your transfer gets interrupted or whatever else. There's always a possibility that you won't detect it. So manual verification, if you're really paranoid, it's extremely rare for a upload to fail or for everything not to transfer. The exceptions will be if you've got really strange file names, like if you've got, say, file names that are longer than 255 characters, for example, or if you've got some really strange characters that might be acceptable in Windows, but they're not acceptable on Linux, or vice versa.
Hey, Wayne, you could use a find command and something that'll give them the file sizes.
That probably that's a more complex thing, maybe not for here.
Yeah, I couldn't type it off the top of my head. I'd have to.
Oh yeah, I know how to do it. But,
yeah, I knew you would.
It's just going to blow away people. So that's another session maybe.
If you want to look into this option, Sebastian, the command they're referring to is called find, and you can enter your file names or a set of file names for the command to find, and it will tell you whether they're present on your machine or not. Once again, if you do want to learn how to use a command and you don't know yet, the man option for manual will display the manual. So if you do want to look into it yourself, feel free to. If not, we might have an option, a lesson later on these topics as well, if there is interest. You could also, once you're within the HPC, list files within all of your directories and check. Yes, Wayne?
Would now be a good time for me to do a mountain duck demo? Won't take long.
If you want to show how to use find, that would be awesome. Okay. I'll stop sharing my screen. Thank you, Wayne.
All right, let's find it now. Yeah, okay. You all see that screen? It's a Mac, so you all see like a Mac screen in front of you?
We see your Microsoft remote desktop.
You've got Microsoft Remote Desktop. You've got applications down the bottom. So Mountain Duck is a piece of software that we've got licensed. I can't remember how many, maybe 100 licenses or 50 licenses. So there's plenty, and we can always increase. What it does, it makes, for those who use Windows, it makes it sort of seamless. So you put in a ServiceNow job, we can give you the license key and you get it installed. It's all documented on that side. It's actually really quite easy. Anyway, I'm just in a Mac here. I open up. I've already got it open, so I then go up here and here's my Mountain Duck interface with the different things I've got. Now I've created some different things, like there's one of these connectors is to Cloud Store, another one's somewhere else, I don't know where. And here's my Zodiac, which is just a save thing. So what I'll do first, normally what you do, you're new to Mountain Duck, you just open connection, and it's similar to FileZilla. You know, you can give it a name, for instance, like HPC to make it easy for later. Obviously, that's the Zodiac, hpc.jc.edu.au, and you can put username, etc. And then, you can do connect. Once you've, set something up, I just then go down here and go, let's connect to Zodiac. And there I've got they're all my files on HPC on my home directory. And I can play with them and move them around however I want. So bang. This is a native, whether it's Windows or Mac, it's native. So you can double click on the file, which is something you can't do in FileZilla and some other apps in many cases. So you can actually double click anywhere there and it'll open up the file in the app that's associated with that file. So, really easy, simple, and makes it look like it's on your desktop. You can do it remotely because you can, using the same port 8822, you can actually connect to HPC from anywhere. For the HPC storage. Just to give you a show, I'll just go into my remote desktop and show you like that, basically the same folder structure. This is how I use HPC. So I can, power outages, things like that, they become irrelevant. The working from home, it's just so much easier working from home if I use this rather than SSH. Sometimes you have to put up with this. It's a little bit slow to get the initial screen. It's faster at home than it is at work, interestingly. I've already got other sessions. So, if you get in, I come in here, I just go open my terminal, and it's a bit hard to see that it's exactly the same, but basically the same files would be there that were elsewhere, but it's just, there's so many files, it's hard to tell. Actually, what I've got to do there, 10.01, so that's actually a different system. I got it wrong. So what you see there, Lorenzo talked before about SSH keys. That passphrase is me using SSH keys. The authentication is done locally, so there's no communication over the network. It's my preferred way of doing things. And now if I go into this directory here, hopefully it might be a bit easier to see that the files were the same. I can't remember which file I looked up before, but that chap 8f9.pdf was the file that I transferred. And that's just sort of a quick demo. As I said, it's really, really trivial to use. It gives you the sort of file share type interface, and it's fully functional. But it can also connect to lots of different platforms. So if you've got S3 storage, if you've got, I assume Microsoft Blob or whatever the storage is there, you can do your OneDrive, your SharePoint. There's lots of different platforms that it connect to and talk to, and it presents it to you as if it was a shared folder or a folder in your local system. Now, as I said, we've got licenses, so all you got to do is put a service now job, and we can hand out that information for you. All right, that's it from me. Thanks, Lorenzo.
No worries. Thanks, Wayne.
Oh, Wayne, if you're using Mountain Duck from a Windows machine onto the HPC, do you have to, and use an editor on your Windows machine, do you have to worry about carriage turn line feeds?
Depends on the software. So some software can ignore the differences between Linux and Windows. The way Windows is very much like an old style typewriter. You do a carriage return and then an end of new line. So you end up to 2 characters. Linux, either one of those results in the same thing. So it's complicated, but some software won't recognize that difference, and you might have troubles. But you have to, that's the difference between Windows and Linux. It's got nothing to do with the FileZilla or anything else. Okay, I'll stop sharing. Thanks, Lorenzo.
No worries, thank you. And another thing, Sebastian, that you will encounter as you work with in a lot of collaborative projects and bigger data sets is MD checksums, which are files that uniquely identify what your file looks like. I'm probably going to give a very bad explanation for it. But basically, if you have a file or a folder, you can produce a mdcheck file for that folder before you transfer it. And then after you transfer it, you produce that same mdcheck file in the location where you transferred it. And then you can compare these two summary files. And if they're the same, means that your two files that you transferred are exactly the same. If you're interested in that, I don't have any material prepared for that today, but we can cover that as well in the future. It's something that you see a lot if you download data from larger databases as large downloads. Sometimes they complete 90% of it, it's missing a bit of it, doesn't tell you for some reason. And unless you do that step, you don't realize. I'm not sure if you can do it for folders per se, or it can only be done on files, but yeah, if you're interested, I'll add that to a session. I think that's a good summary of ways in which you can transfer files to and from the HPC. I mentioned it in the chat, but I'll try and include what Wayne showed into our course material on our website. So look there in the next couple of weeks, and I'll add instructions on how to set up what Wayne just showed us. Next session is going to be how to run R and scripts within the HPC. Before I get there, do you have any questions? Were you able to follow along if you tried? Any pointers or suggestions? I don't see anything in the chat and I hear crickets. So I'll move along. Feel free to interrupt me at a later stage if you need to. So I'm going to share my screen again. And I'm now going to log in into the HPC. And we can see from my user ID and the login node that we're now in logged in within the HPC successfully. We're now gonna start running R in 3 different ways. First, we're gonna run it interactively. This is gonna be very similar to how you will run it on RStudio from the console. We're then gonna write a script and run the script at once. And then we're gonna submit a job with that script. If that's unclear to you, don't worry, we'll break it down in individual steps. The reason why I'm showing all of submitting jobs with R is because in my experience, most of the people that came to me asking me how to use HPC, they had some familiarity with R and they often already conducted parts of their analysis in R. And it's also what I'm most familiar with. In the future, we do want to expand this material. So if you have experience with Python or other things, please feel free to add on our lecture material online. If not, when I have time, I'll get to it myself, hopefully. Okay, enough blabbing. Let's start actually writing some code. So you might ask yourself, how do I run R from the HPC? In the past, we used to use modules. Now we're switching to singularities. So today I'm going to stick to Singularity only without explaining too much in detail what they are and what they mean. We'll have a whole session dedicated to singularities and how to work with them. For now, just note that to run, yes, Wayne, I heard you.
To intervene, Lorenzo, you actually don't need to use the singularity command at all. So if you do module avail R, space, sorry, yeah. Yep. So R412 is a singularity container. So if you do now module load R/4.1.2.
Sorry, I forgot what to type.
Yep. So now just type R. So basically, you're using the container without even knowing you're using one. That's a lot of the work we've done recently. That's what we're aiming to do. We're trying to make the containers absolutely seamless to 99% of people.
Okay, that's very helpful. I was not aware that was available yet. Okay, then forget about containers and the first line of code, I'm gonna quickly show again what we just did with Wayne so that you can follow along. We loaded a module. If you're unfamiliar with what that means, think of it as running the library command on R. You're making a package or a software that's already available to your current working environment. It's already been installed, but is not loaded. So what that module load R command does is make that software available. In this case, it's a Singularity in a container. Don't worry about what that means. If you are ever unsure of what exactly is the name of the module you want to run, you can see what modules are available with the module avail command. I retyped it at the bottom. And you can see that there's a lot of modules which include genomic tools like VCF tools. They include R, as we just saw now, as well as, where is it? R10, if you're doing analysis that requires 10, and a lot of other software and packages. So you've identified, or maybe you already know you're looking for a specific version of R, you can add R to the module avail command, and it gives you the four available instances of R. Yes,
you can, you know, if you're not, you know, you don't have to type everything. So if you did just like a modular avail FFI, or, you know, some part of a name, so, you know, say align. If you did modular avail align, you'll see any piece of software with align as a word in it. Oh, I actually don't. No, I must have to start with it. Sorry. So if you did modular avail ZA, you'd get anything with ZA. Yeah, or modular avail lib, we'll get everything with lib.
So we've identified, thank you, Wayne. So we've identified the module that we want to run. In this case, we're going to run the latest instance of R, which is 4.1.2. So we need to load it. It's already loaded, but for sake of clarity, I'll show again. You run this command, module load R 4.1.2. And then once it's loaded, you can actually run R itself. And to do that, use the R command. Press enter. And you can see that we're now running our version, where did it go? 4.1.2. There's a bit of information. I'm not sure what this means, but I don't think it's.
Carl's not set it up perfectly, but it doesn't matter. It's not going to interfere with you.
Yeah, you can ignore this. As long as you see this screen pop up, means that you're successfully running R. And you can see that our command prompt here on the left changed. It's not anymore what I had before with my GC number, blah, 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 with at the end the % sign. We now have the greater than sign. So what's happening now, we switched our language from bash to R. So if I try a bash command like ls, it's going to tell me, no, that is what about pwd for print working directory. It tells me it doesn't find this object or function. Because in R, to get our working directory, we use instead get wd. And you can see that my working directory is my home directory within the HPC. And I can use all the commands that I will use usually in R, like list files, and see what files are available. And I can start writing some R code for my analysis. For the sake of today, I'm going to use one of the pre-installed datasets in R. I'm going to try and make the example in the lectures a bit more relevant in the future. I just ran out of time last night. In this case, we're going to use the USA arrest dataset, which you load with the data command, followed by the name of the dataset in quotes. That's where this worked yesterday. What about empty cars? Yay. Okay. If you're unaware, these are just a number of datasets that come pre-installed with our versions that you can use for test your code or for learning purposes like we're doing today. So if I look at empty cars now, I can see with the str command for structure, I can see that it's a data frame with 32 observation of 11 variable like MPG, cylinders, and so on. Don't worry too much about what this data mean. Just know it's a data frame we're going to play around with for a bit. And maybe I like to plot it with Ggplot because it's my favorite way for plotting. And I can load the Ggplot library as so. That is because most commonly used packages in R are already installed on the HPC, so you do not need to install them yourself. If you happen to load a package, I'm going to make up a name like my view package that you know exists, not one that you just made up like yourself, and it tells you there's no package called my build package. Then the way to go, instead of installing it yourself, tell me when if the device has changed. Submit a ServiceNow request through the GCU ServiceNow portal, spelled as so. Submit an IT request for that package to be installed. Is that still the advice, Wayne, or would you like?
Yep. Yeah, and the beauty there is it saves file count in your home directory, and it far less time. If everyone's installing a package, you're all spending the same amount of time installing that package, whereas I install it, one person installing it once.
Thank you. And you'll find that because we have a lot of users at GCU and these packages has been installed throughout the years, you'll very rarely encounter a package that's not available unless it's a new one or a very niche one. So we now have Ggplot and we can start making a plot. I'm going to plot my plot. I'm going to call my plot P1. I'm going to use as my data set empty cars. And I'm going to add a geom point where I'm comparing on the x-axis the number of cylinders, and on the y-axis the MPG, which I'm not sure what it is. And I'm going to add a beautiful theme, classic, because I like that theme. And maybe I want to now save this plot to show my collaborators or to see it myself. And I'm going to use the ggsave function. I'm going to call it my, I'm going to give it a directory, my home directory within the HPC. My beautiful plot.jpg. The plot that I'm plotting is P1, and device is JPEG. Say 77 emails. If I now look at my files in my own directory, I can see my beautiful plot there, but within the HPC alone, I cannot see it. So maybe I'm gonna quit R and not save the workspace. And now I can transfer it with SCP to my desktop. I don't believe. I have a question for a more experienced user because I honestly learned SCP yesterday. Can I use SCP within the HPC? Okay.
You need to know the foreign address, that's all.
What would the foreign address for my laptop be?
You can work that out, get an IP address.
Okay, I'm going to use a shortcut because I don't have time to find my IP address. I'm going to momentarily exit the HPC. Make sure that I save my file name and remember where it is located. And now I'm going to use SCP. Now you can see the prompt. No, it's not common. Host name. I can see that I'm now on my MacBook. If I type host name and it return the login node, I'll know that I was in the HPC. You can see that the prompt and the directory are different as well. Within users, my username is Lorenzo on my desktop and I'm on the desktop. So refresher for SCP that we used before. I want to transfer from the HPC. So I enter my HPC username. I think it's that I forgot my ID. Double quote, and then the name of my file that I saved. And I want to transfer it to my desktop. Ask me for the password. I entered it wrong. Okay. I entered it wrong. I forgot one number. Sorry about that. A beautiful plot transferred 100%. And now if I look at the files on my desktop with the ls command, I can see that is there. And I'm going to show it to you for the sake of showing the beautiful plot. It's going to tell us about the relationship between MPG and cylinders. Were you guys able to follow so far if you haven't used R in the HPC before? And do you have any questions or comments or additions? Okay, so good so far. Oh, a question. I see a question. Oh, thanks, Pauline. So for the future, probably learn your IP address so you can transfer directly without having to log out of the HPC, because that's a bit cumbersome. What I just did? Oh, again. I'm logging in back into the HPC if I manage to. Hey. Oh, good point, Agana. I could have just opened a new terminal with shell, new window, and done it with that. That's also a good point. So that's all fine and dandy, and it's good for figuring out your code, what works, what doesn't, and so on. But think, for instance, of the case where you did this plotting of your data maybe 1 month into collecting the data, and then 3 months later, you get more data, a more complete data set, and you want to replot it again. And maybe it wasn't as easy as an example as mine. Maybe you had to do some data manipulation, some filtering, and so on. If you just did as I did right now, you'll have to start again. And you probably experienced this in when you first started using it. If you just type comments in the console and type them, they're not saved anywhere, and you have to rethink them and refigure them out at a later stage. What instead you can do, and you probably do already when working with RStudio, is write scripts that you can reuse. How can I do? How can I write a script then within the HPC, and how can I use it within the HPC? Disclaimer once again: this is how I do things. Feel free to do it your own way. You might want to use VS Studio Code or other ways. If it's a simple script, I might just use Nano. In my home directory, I'm happy to create the file here, and I'm going to produce my R script.r, put in the R at the end to highlight how that's an R script. I already produced that. Let's do it again. So what did we do? We loaded our empty cars dataset, and then we loaded Ggplot, and we then plotted with Ggplot our empty cars data with a geom point function using s, x equals, I'm going to make it up because I forgot. I'm pretty sure these two were in there. And then I save this file. So I give it the file name. And important when you write the scripts is to have a very good understanding of the directories you're working with and where you want your files to be saved. I mentioned in the lesson last week how you can use the tilde, which refers to your home directory to create absolute paths. What that means is that if I then move at a later stage this script into a different directory and I run it from there, this path is not gonna break, because even though I might be in a subfolder of my home directory, it still knows what this means, and so it still knows where to save my file. My view plot .jpg. The plot that I'm plotting is P1, and then device is JPG. And maybe good, and I can also comment just as I will do for my R script, my file, load data, load packages, plot data, and save plot. Now I'm a bit OCD, so I'm going to make sure that there's 2 hashtags there and a space. So done, you wrote an R script. It's not that different from what you will do in RStudio or what you will do in Visual Studio Code. Exit with Ctrl X, save with Y, enter. And now if I look in my directory, I can see that there is my R script here. How do I then run this R script within the HPC? You'll have to load R. If you haven't done so, I've already done it, so I don't need to. And then you use the R command with the F option, which means I'm not going to give you the code. I'm going to give you a file or a script with the code. And then the name of the script, and I can press enter. And I logged out of the HPC, so I need to load R again. And now that I've loaded R, it's working. It first started R and then ran all of my comments in a succession without needing my input. And now if I look at my directory, I can see that my beautiful plot with the wrong extension was created. While we're at it, we can maybe learn how to rename files, because I think I covered it last week, but quickly. And one way to do that is with move. I enter the file that I want to move and where I want to move it with the new name. And now if I do ls, I can see that my plot has the right extension. Not going to transfer it and show you the file again, because it's not going to be that informative, but just know that you ran a script with all of your command from the HPC and it produced an output. Yeah, thank you, Wayne. You can do graphical, as in like you have the option to see, visualize the files that you're producing within the HPC. And as Wayne said, there is documentation on that on the GCU Confluence website. If there is interest in that, please state it in the chat and we might do a session on it at a later stage. So we saw how to run R interactively and we saw how to submit R scripts. But you saw that while this R script was running, I would see the code that was happening and I did not have the option to enter new code. What would you do then if while your script was running, maybe it's a script that takes 4 hours, you want to do other work in the HPC? Or what if your internet connection cuts off or you need to run to a meeting and you close the terminal? That script will stop running as well. And that is a big part of why you're here today, to be able to submit these jobs without having to worry about them. You can exit the HPC, your computer can die, someone can steal it, chuck it out of the window. Your job is still gonna run as long as you submit it. So how do you do that? Well, we got the first step set up, which is our R script that we want to run. Now we need to produce what's known as a PBS script, which will give the information to the job scheduler as to what resources you want to your job. What does it mean? It will tell the scheduler how much memory you want, how many CPUs or brains you want to use, and other additional information. If that's a bit confusing to you, let's have a quick refresher on the Hpc structure, which we introduced last week. And we know that these are on the file. Can you all see the Hpc structure image before I go any further? I heard the mumbled yes.
Yes.
Let's see. Oh, awesome. Thanks, Wayne. So we were on our laptop. We used the SSH command to log in onto the Hpc, and we're now in the login nodes. These are just as powerful as the compute nodes, 40 cores, same RAM, but they're used mostly for testing your scripts. As Wayne said last week, feel free to play around in these, but they're not your end point for your analysis. Once you've played around, once you make sure that your script works, that they produce an output, that the output makes sense, and so on, you might want to upscale. Maybe you want to submit 40 jobs that all do the same thing, but with different parameters, if you're testing parameter space for your models. If that's the case, then you're not going to submit 40 jobs that require 10 cores each on the login nodes because there's not enough resources. Instead, you're going to use the qsub command, which I'll show you in a second, to submit a job to the PBS server, which will then submit it, sometimes through a scheduler, to the compute nodes. And then your jobs will be run in the background from these compute nodes, and you can log out and they'll still be running. So how do we achieve that? As I mentioned, we need to produce this PBS script. And just like any scripts, you can write it into any text editor. I like Nano, I'll do it in Nano. You can do it in VS Code and so on. So I'm going to write Nano, my PBS script version 2, so we don't see the one already prefilled. I'm happy for it to be in my home directory. I press enter, and I now have an empty text file. There's 3 parts to a PBS script. The first one is the shebang. Then you have the PBS options, and at the end, you will have your commands to run. Let's fill them in one at a time. The shebang, I believe, tells the scheduler in what language your code below is going to be in. In this case, we're going to write with Bash, which we're familiar with, is the same language that it's used as default on the Hpc. And I believe this is telling him where the executables for that language are located. I'm not sure, maybe Wayne can correct me. But if you just want to write in Bash, that's all you need on the first line. Then for our PBS options, we're going to start getting into the realm of resource allocation. For instance, I might, for this job, it's a small job, I might only want 1 CPU. So I'm going to write PBS, the option L, and then the argument and CPUs, and give it 1 CPU. If I need to run something in parallel and I'm running 10 jobs in parallel, then I might require 10 CPUs. Then you want to enter the memory allocation so that the scheduler gives you just enough memory, or just enough memory to run your job without requesting all of the memory available on the Hpc. And once again, we start the line with hashtag PBS followed by the L command, and then mem. And in this case, it's small job, so 50 megabyte. Less would have probably done, but it's not too much. Should be all right. And then we're gonna give it a wall time, and this states how long the job is gonna run for. And if your job runs for longer than that, it's gonna terminate. This is a quick job, so 30 minutes should be all right. And then maybe I'm submitting many jobs at once. I want to keep track of them separately. And so I give them a name. For instance, here is plotting my data. And I give it the name with the PBS, the /n option. These are the basic options you need to run a script. There's many more for you to explore and figure out. I think for today, especially because we're late, I'll leave it to here. Good question from Sebastian. What if you don't know your wall time? Do you have to specify one? Maybe I let Wayne answer this question because I think he'll have a more accurate answer, if that's all right. Wayne.
By default, you don't need to specify one, but I think my configuration requires you to specify one. You can just, initially anyway, you can just specify something very, very large. So if you think it might take 3 days, you can go like, 720 hours. That's way more than 3 days. Eventually you want to get it more accurate. The more accurate you get it, the better. Especially if you move on to larger facilities like NCI, where they expect you to be very accurate in your requests. At JCU, I really, I couldn't care less whether you're accurate or not. Usually, if I intervene, it's because someone else was contacted me and said, "Can you please tell Lorenzo to, get his requests more accuracy," or something like that. That's the only time I'd ever intervene, because ultimately the cluster exists for you, not for me.
Yeah, great. Thank you, Wayne, and great question, Sebastian. I think this has been a topic that has been brought up, like how to figure out how much memory you need. And time and so on. There's ways, we might cover it in a little lecture. One way would be, say you're running iterations of a model and you need to run 10,000 iterations because that's what you need for your model. Maybe you'll start by running 100 and see how much time that takes, and then make some calculation, be a bit conservative so you have an extra more, and you can figure it out that way. If you're running unique lines of codes that you've never run before, then you can't really know how long that's going to take. So maybe be conservative, give it a few days. Usually you get a feel for whether your code is going to be 1 or 2 days. And usually if it's in that realm, it's not going to be a problem. If it starts taking 2 weeks, then you'll know that it's going to be a long job. So you might request 2 weeks and so on.
Some of the software, I know there may be no easy way to know how long the job's going to run. For instance, Mr. Bay's software, I remember years ago, it depends on the data set you provide. So, I understand that, and that's why I said I don't provide any penalties. I think the maximum time you can request is 1,440, which is 3 months, roughly. But the more, as I said, the more accurate you get the request, the better the scheduler does. And that better the scheduler works, the quicker other people can use the time that your job would have used otherwise. It's complicated to explain that, but that's why NCI and places like that want everyone to be absolutely accurate, because the more accurate it can be, the more consumption they can get out of that machine.
And I adjusted my syntax to match what's on the JCU conference, so you guys can learn in the proper way and not the old way. Okay, we got the first 2 parts done. Let's finish this up before you guys have to run to meetings. What do we want to do now? We want to run R script, and we know that the R script is run with the R command, F for file. We're going to use an absolute path, so no matter where we run the script from is going to work. We know it's in our home directory, so I just entered the tilde, and then I forgot the name of my script. I think it was my R script. .r. This on its own will not work because your job that's being submitted is as if you're logging into the HPC again. It does not have R loaded as of now. So the first thing we want to do is to load our module. Module load R 4.1.2 as we did before, and then run our script. And that's all you need in your PBS file. We can save it, Ctrl X, Y for yes, enter. check the name was correct, and maybe I can do a quick check this way. My PBS script 2. Oh, I misspelled script. It's good. I called it myrscript.r. That's the right name. It's in the home directory. All fine and dandy. Now we can submit the PBS script with ends with an sh extension, and we'll run within that the R script with the qsub, and then the name of my script .r. It's given me a job ID, and I can check the status of my job with the qstat command. This was a very quick job, so it's already finished. But say I was running some graphene simulation, I gave them this name. So this is the name that we gave. Sorry. This is the name that we gave it here, plotting my data. So if my script was still running, if my job was still running, I will have that there. This is the ID for the job that you might use, for instance, if you want to stop the job because you notice there's something wrong and you want to rerun it. This is your ID. The time usage, its status. R is for running, Q is for queued, so it's waiting for enough resources to be available. This is particular status for array jobs, which we won't worry about for now, and a quick description of what kind of job it is in terms of resources and how much it's going to run for. If everything worked, my R script should have produced my beautiful plot. I believe this time it didn't work, as it gave me. Oh no, it ran. $12.07. Okay, there was probably an error in something I did. There's an error somewhere in there. We're not going to worry for now, because the main thing I like to focus on is, was this process clear for you guys? Do you have any questions? I'm sorry I rushed it towards the end and it's 10 minutes past 12. Is there anything you'd like me to cover again? Was this useful? And what would you like to see in next sessions?
I think it was really useful.
Thanks, Natalia, you're biased.
I'm not. I haven't run R. I don't use HPC to run R, so it was really cool.
There is
Thanks,
another
Lorenzo.
video.
It was super useful. Can I something? I'm still very confused with the singularity thing. So if you could have a session on that would be amazing. Like, for example, I don't understand why now, how did we run the singularity without actually calling the singularity? Like, I don't understand, you know, how do we know whatever the software we're using is already built into the singularity? Because usually like I run, you know, run singularity run and then the name of the software. But in this case, it was not needed for R. And I don't understand how we know when it's needed.
It's not needed for most things. So I'll just give you a quick, I mean, I know we're over time, but I'll just, you know, it's probably beneficial to do it now, just briefly. Just wait, give me a second. You can see my screen?
Yes.
Okay, so if you do module load R34.1.2, what you'll see there is it's available in an Attainer. Attainer is the new name for Singularity, as in terms of a product name. So it's telling you straight away, you know, you're using, you're running the software within a container. You know, if you want to see what aliases are available, you know, that message is also showing you that. So if you do module show R412, you can see you've got some shorthands here. You've got R as an alias for Singularity run, blah, 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 R. R script is the same thing with an R script at the end. And you can also see, you know, So some people, high-end users, may need to use Singularity because of options that are available in Singularity. They might want to pass a strange directory, or they've got an S3 bucket and they want to pass that into HPC. There's reasons that you might still want to use Singularity, but for most people, what these things will do is show you these aliases make it easy for you to use. So, and every one will be set up like that. So let's say we've got module load velvet. What is it? 1.2.10. So same deal. You get the same message, and you go in there, velvet, and you get here's a different set of aliases that are available for the velvet software. But again, in that initial message, you're using an apptainer. So if we go back to R, module purge, we'll get rid of all the module information. Module list R, avail R. Now, if I was to go back to module load, really old version of R, which no one should be using, but we leave it there just in case someone needs. You see no message. There's nothing there saying it's a container. There's nothing there. It's really old style stuff. So that's what the difference. When you've loaded all these modules and you're thinking, oh, what have I got loaded? You can always just do module list. It'll tell you everything that's loaded. Right. So as Lorenzo said, modules are there just to make life easier for everyone. There's a lot of software on HPC as that module. Let's actually maximize this. Module avail, and you'll see exactly how much software is on there. If you were to modify your .bashrc file to point at everything there, it wouldn't work. The path would be so long that it wouldn't see it all. We've had a person in the past that basically did that, and they got to a point where the path got so long that they couldn't see half the software they wanted. So that's why module variables exist. But the other thing it gives you, again, for that reproducible research, you know exactly which version you're using. So when you're doing a module load, you can do module load, say Ggplot, for instance, and it'll give you whatever one I've decided. But the problem is, if you're doing, if you're wanting to do reproducible research, that doesn't tell you which version you use, unless in here it's got, you've got that information. But in the old style, and maybe down in the future, I might not have that information, which is module load, blah blah blah. So it's always best to module load giflib, for instance, /5.1.4 if you wanted to use that particular version. That way, it's in your record. So when someone comes, if someone comes back to you and questions you about some result you've published, you can go, here's all the things that I did. Here's the container I used, and they can just download that container and they can reproduce what you did, just like that. So that's what modules are for, and they're absolutely essential in a HPC type environment because not everyone yet wants to use the software. So let's say Lorenzo might want to use, let's say Velvet. Oh no, not Velvet. It's not a good example. Say Trinotate 3.2.1. Someone else might want to use Trinotate 3.2.2. They can't coexist. You can't easily use both at the same time. So one's going to sit because the commands are the same. So one's going to hit, not the other. That's the reason.
Thank you so much for the explanation. Thank you. It's very useful.
Awesome, Wayne. Thank you. Oh, Sebastian left. I wrote a lot to him. Any more feedback or questions?
So next week, maybe like if people want to work on their scripts or like submitting their jobs, and if you guys have any issue with it, maybe they can bring it to the